section 1.5, which is about the conversion of units. And before I go on, I'm going to mention to you that I have put this file here under helpful PDFs. You can go out and see the inside covers of our text. And in the inside covers PDF, the second page of it will have some conversion factors. Now, these give conversions of length, mass, volume, speed, force, work and energy, pressure, and power. You'll notice I've added over here 2.2 pounds equals 9.8 newtons. Both of those are the weight of 1 kilogram on Earth, and 4.448 newtons is 1 slug foot per second squared. I've also put in my little mnemonic, Yuzaf Panum Kumgit Pezi, and then I've got over here centa, deci, deca, and hecto for the other powers. I've also got some mnemonics that we're going to use in the first 3 chapters or so that I won't get to right away. All right, well, let's get straight to the first example problem. If a car is traveling at 28 meters per second, is the driver exceeding the speed limit of 55 miles per hour? So the question in mathematical notation, you might write it like this. Is it greater 28 meters per second than 55 miles per hour? Well, we can do this one of 2 ways. We can convert the 28 meters per second to miles per hour, in which case, look at this. They've got a speed column directly in this section. We can see that 1 mile per hour is 1.61 kilometers per hour. There's 2 ways to write this. We can say 1 mile per hour over 1.61 kilometers per hour is equal to 1. Or we can do the inverse, or the reciprocal of that, 1.61 kilometers per hour. I should use the meters per second, shouldn't I? Let's do this. Because let's say 0.447 meters per second over 1 mile per hour equals 1. This is called a conversion factor. You can do this way, or you can flip it and do it 1 mile per hour divided by 0.447 meters per second is either one of those is going to be 1. And the reason it's 1, it's a ratio. These 2 things are the same thing, even though they look different numerically and the units look different, but they're actually the same thing. They measure the same quantity of length. So when I do a conversion factor, let's say I want to change meters per second, 28 meters per second. Well, let's go ahead and put meters per second on the top. In order to get that converted into miles per hour, what I do is put meters per second on the bottom. So the meters per second and meter per second cancel, and put miles per hour on the top. So I'll put 1 mile per hour on the top and 0.447 meters per second on the bottom. And we'll find out what that speed is. So I'll get out a spreadsheet program and type in equals 28 divided by 0.447, and it pops up with 62.6 miles per hour. 62.6 miles per hour, and that is 62.6 miles per hour is greater than 55 miles per hour. So that one comes out to be true. So let's remember that this thing is called a conversion factor. And generally, a conversion factor is something that comes out to be 1, even though it's got numbers and units in it, so that you can convert from one unit to another unit by stacking it kind of like that. Example 1.5, it says the traffic light turns green and the driver of a high-performance car slams the accelerator to the floor. The accelerometer registers 22 meters per second squared. Convert this reading to kilometers per minute squared. So this one we really shouldn't have to look up anything because 22 meters per second squared. We're going to multiply this by, we're going to get rid of the seconds squared. So I'll put seconds up here and minutes down here. How many seconds are in a minute? There are 60 seconds in 1 minute. And then it's very important that we note the square here. Since we want it in minutes squared, we'll put a squared there as well. And then we want to have kilometers on the top and meters on the bottom because we want to have it in kilometers per minute squared. So how many kilometers are in a meter or vice versa? There are 1,000 meters in 1 kilometer. And then we multiply that all out, which is going to be 22 times 60 squared divided by 1,000. So I will type in equals 22 times 60 squared divided by 1,000. And it comes out to be 79.2 kilometers per minute squared. Now that means that after 1 minute, he'll be going 79.2 meters per second, kilometers per minute. I'm sorry, kilometers per minute. And if he kept accelerating at that rate, by the way, that's ridiculously fast already. But if he kept accelerating at that rate after 2 minutes, he would be going, what is 79 times 2? 79.2. Oh, I'm filming the screen. Okay, 79.2 times 2 equals 79.2 times 2. Sorry. So you'd be going 158.4 kilometers per minute after 2 minutes. How fast is that in meters per second? Let's look at that. Well, let's just get an estimate for now. This would be 79.2 kilometers in 60 seconds. So it would be well above 1 kilometer per second. It would be, yeah, it would be a little bit more than 1 kilometer per second. So how does that make sense that this guy that's going 22 meters per second squared gets up to 79.2 kilometers, or gets up this fast as 1 kilometer per second, over a kilometer per second? Well, generally this acceleration won't last that long.